Hey there, welcome to another video on the Learn APL with Neural Networks series. In this video what we will do is, or actually what I'll do is teach you about bracket indexing and how to use bracket indexing with Boolean masks to visualize something, or rather how to use bracket indexing and character vectors to visualize Boolean masks. So if you know all about these subjects, feel free to skip this video, otherwise just tag along. So let me go ahead and use the roll primitive to create a bunch of random numbers, right? We've done this previously. And there you have it, a bunch of random numbers. But what I wanted was to assign them. So now I have a vector with random numbers. Let's see which ones are greater than 0.5. And we have this Boolean mask. Now this is fairly easy to look at, but if I wanted to get fancy, maybe I would want to replace the zeros with, I don't know, blank spaces and the ones with asterisks, for example, or something like that. And so how could I do that? Well, let's see. Let me type a blank space and an asterisk here. So this is a character vector C, right? And it looks like that. Now, what's the tally of C? C has two elements. Now, I could do something which is index into C with brackets. Now what these brackets here are doing is I can type indices in here. Well, this was terrible because I can see it, but I can type indices here and I can access the elements in C. And the cool thing is I can give more than one index and it will index with the successive indices. So 1, 0, 1 fetches the elements in position 1, then 0, then 1. And I can keep going like that. Yeah. And so basically what I can do is type in C and then open the brackets and say, well, can I please look at the values that are larger than 0.5? And this encodes the positions. Well, maybe the blank space isn't a great thing because now I can't, it's not obvious, it's not visible where the thing ends, but I could do something like quad and then asterisk, for example. And I can do the exact same thing, right? And I can also do this with the MNIST data. So what I haven't told you yet, actually, let's not get ahead of ourselves. So let's just show you the technique now, and in the next video we will do that with the MNIST data. So the technique is essentially this. Now this can be extended. Well, first off, you don't need to create the variable beforehand, so you could do something like this. Okay, you can index directly, and you can also you can have more elements in here. So for example, a dot, right? And you can do 0, 2, 1, 0, 1, 2. And it works the same. Now, something really important here, and I kind of forgot about it. Something important here is to take a look at quad IO. Now, quad IO in my computer is 0. And what that means is that my indices start at 0. If for some reason you have quad IO set to 1, and by for some reason I mean something as simple as the default from the installation. So a default installation starts with quad IO gets 1. So if you have the default, when you try to do something like this, index with a Boolean mask, it fails. Why is that? Because a Boolean mask is always zeros and ones. It doesn't depend on quad IO. So when you try to index with the 0, it gives an index error, because when quad IO is set to 1, the indices start at 1, not at 0. So you would need to do something like indexing, but do 1 plus the Boolean mask, and now it works. Or you can set quad IO to 0, and you don't need to add anything. So there's that. And then there's this really cool thing, which is how many elements are there in V? There's 10. So I can reshape V to be a matrix with, say, 5 rows and 2 columns, right? Now V looks like this. But I can still ask the same question. So can I please see where V is larger than 0.5? And now what's really cool is that this thing over here this is still a Boolean mask, but it's a matrix, right? But when we index into this character vector, the result respects the shape of the indices. And I think this is really interesting and really cool. So I don't need to flatten V and then reshape the result to match the original shape of V. I can just do this. Okay, so this is something to bear in mind in the next video. Okay, see you there. Bye.